For this one, we're going to talk about principal component analysis. Principal component analysis, or PCA, is an unsupervised learning model. It's great when you have a large amount of data in terms of dimensions and rows, and it's unstructured. So it tries to make sense of that, and it can try to figure out what components within that to use, be able to make sense of it, or you can manually set it. Here we will create the PCA object and tell it to use one component or one row of the two in our data set. Or you can set it manually and tell it which one to use, and then you can generate your own component. So two methods: let it figure out, or you can tell it. And again, you can do more than one, which is what I show here. You can tell it here how many to keep, which ones specifically to keep, and here you can tell it how many to keep, and it will figure out which ones to keep. So here we're using one component. We're going to fit and transform, which fits the PCA model to our data frame and applies dimensionality reduction. Again, one of these has got to go, and it's going to figure out which one goes. And then here you can just, this is just to give a variance rate ratio and singular values corresponding to the selected component. These, if you look up PCA on the sklearn site, right here, if you search for that, look at sklearn.decompose, import PCA, it'll tell you every attribute and every value you can get from this. But the point here is to show when there's one value out, you can see I have one variance rate and one singular rate, and then it has PCA components applied on my whole data set on row 1. So that's here. I let it figure out, the model figure out. Here I said keep row 1, and that's what it shows there. So I changed that and I used 2. Again, we only have two columns, so we're going to keep that. We fit on that. We do the same printouts of ratio and singular values. But here our data frame, we're telling it to keep both rows, and then it will print that again. So, but since we're keeping both rows, we're going to get variance rate ratios for both, and we're going to get singular values for both. And then our PCA components, the whole data frame, is going to be the numbers for the entire 1,000 rows, 0 to 99. And then if you use this for your final project, I added in a plot to show that you can plot on something. You could plot on variance and singular rate, or just do one for the final project. But here I do the variance ratio. I get it into a list. I then get the index, how many are in the list, which is 2, right? As we can see here, there are 2 values. I'm getting the index based on the length, turning that into a NumPy array. And then I'm doing a bar plot with a NumPy array for my X and my values for my Y axis. Then I'm going to pretty it up with the title, X label, Y label, and I'm going to show it. So that will come out. Not much to it. Oops. So there it is. We can see here's our row 1, here's our row 2. Row 1 was at 0.51, so it's just above, and the other one, row 2, was 0.48, so it's just below. So there you go. There's more on that in the textbooks, or you could further research principal component analysis. You may want to do similar if you pick the unstructured data set for using both k-means and PCA, but I leave that to you. That's all I wanted to show for the principal component analysis, but just know it's a great algorithm that can quickly do dimensionality reduction on large unstructured data sets.